Welcome to the session. Greeting of the day. In today's class, we are going to see about the various types of control valves available to actuate this mechanical actuating systems of hydraulic actuating systems or pneumatic actuating systems, whatever it is. The flow may be a fluid or flow may be the air, pneumatic, whatever it is. We are going to understand about the control valves, how it is, whether two-way, three-way, ball valves, poppet valves, what are they available, that we are going to see. Now let us consider the flow control valves. The flow control valve is nothing but how much the flow. Now we have direction we have fixed. How much should flow? Whether you see, when this threading adjustment to screw is completely open, as like the tap is opening and closing, whether the flow should be light 5 liter per minute or it should be open large 20 liter per minute. So that I am adjusting. So see here, as per the image, the flow rate will takes place very minimum. In this path it will takes place. So in this path, the flow rate will be available, very minimum. It comes here, it is pressurized here, and it moves. Now, I have moved upward. What happens? Instead of one flow, multiple flows are possible, and we can. This is 5 liter per minute, for example. If it is completely open, what happens? It is I am telling this is a 20 liter per minute flow rate are possible. So that's the flow rates are done. So for that I have taken a plug and glue valve, butterfly valve, ball valve, balanced valve. So this is we have to see plug, butterfly. It means the valve, the opening valve will be in the form of butterfly. The valve opening in the form of ball. This is ball. The valve opening, it is in the balanced, both two ways, to A and to B. Balanced it will take the exit. So that we will see one by one. See here, it is plug valve. See here, the plug is not a ball. The design is changed in the form of plug. We have to, as usual, we have to thread, and the fluid flow comes here. When it is lightly opened, as of now, 5 liter per minute, right? And I keep on opening, and more space we are getting, and now with respect to converted into 20 liter per minute. This is one is called as plug valve, the design. Now I am coming to the butterfly valve. It is opening in the two directions, whether this one or this one. When the flow happens vertical, instead of this one, I am converting this as a vertical. I am converting this as a vertical one. What happens? It is totally blocked. It is totally blocked now. Right? When it is rotating lightly at this position, here it can go. Similarly here, it can, lightly it is moving, here also it can go. What happens? This I am naming this as a 5 liter per minute, for example. Now, instead of this, the position is like this, straight. The position is, you can take in such a way. In such a way I am taking. So this is the vertical positions I have. Now, in this position, the large area is there. You see, this is the large opening is there. Here also we have the large opening. So large opening here, inlet is how much? It is 20 liter per minute possible. Here also 20 liter per minute are possible. So this is, looks like a butterfly. That's why I am naming this as a butterfly valve. Now I am naming this as a ball valve. Ball valve does not mean it's like a thread. It is like a, this is I have named same similar pattern of ball is there. When it is moved up, totally the gap what is available, in this gap it will pass through. But here also you see, in this method, same butterfly method we have done. When the ball is rotated straight, the path, the volume is the same here, right? The volume is the same, it goes in this way. When the same content is rotating in halfly open, when the same position comes here, what happens? This position comes there, what happens? Half of the ball will be here, half of the ball will be open. In such a way, little amount will be blocked or unblocking conditions will happen. So such deviations are little bit deviations can be done. And the balanced valve, you see, balanced valve, for these conditions, I'm not considering about the ball, I'm not considering the butterfly, I'm not considering the plug valve. Anything I am taking, here I have taken the plug valves. So plug has been taken, fluid in happenings here. Fluid in happened here, and from the in, I can able to, when this piston is moved up, the spool is moved up, what happens? Equally in up and down, it is distributed, little amount distributed. Let us consider 1/3 has been occurred. At the time, here also 5 liter per minute, and here also 5 liter per minute occurred. Now, it is again 2/3 is occurred. What happens? It is increased to 10 liter per minute, and here also increased to 10 liter per minute. So likewise we can keep on increasing and equally distribute, and after coming here what happens? After coming here, it converted into here fluid, both merged to have a fluid output. So therefore we have some control, pressure control we can able to do in such cases. Now I am coming to the last category. I have divided direction control valve, flow control valve, and pressure control valve. Now we come to the third one of pressure control valve. In this third one, the pressure relief valves are used to protect the hydraulic components from the excess pressure, essentially required for safe operations of the system. Its prime function is to limit the system pressure for the specific range. So how much pressure to be went through, that we have to block them. So types, direct type relief valve, when the pressure is reached, it will release all the fluids or all the pneumatic airs, it will release. It will not stop, it will make it to zero, it will not control. It is an unloading valve, little bit it unloads and again come to the pressure maintenance. Pressure reducing valve, sequence valve, counterbalance valve. You see, here, this type of valve have two ports. One which is connected to the pump, and another one is connected to the tank, pump or compressor in case of pneumatic. So I have how much pressure to be controlled. Such pressure pump is released there. So here we have the pump, here we have the pump controls, from there it comes down, and here also tank operation is there. From if the high pressure is there, it immediately goes to the tank. For the exit I am keeping there, and this pressure makes the opening, how much pressure from the pump, how much pressure is needed to move the piston operation. Here the loading conditions will be there. The loading, unloading, it takes place here. It means the operations above this is happening. I want to do the operations, upward operations through the spring operated plunge method is we are doing, but how much pumping? I am giving the pumping of force. That force, if it is extra force is given, more fluid will come in. At the time I am taking the exit of tank to the drain. So similarly here also for unloading relief valve, what I am doing, here the remote operated pilot pressure is there, and the pump is controlling the action to take the spring inside. And now when it is lifting upward the tank, here also it is connected to take the exit. It unloads the fluid flow when it is moved upward direction. So here it is locked now. Here it is locked. When the piston is heavily loaded, it will pump to take the exit. So simple methods we can able to do. Pressure reducing valve. Pressure reducing valve, you see, similarly the pump is activated here and it is ready, and when the spring is given downward or upward direction due to high pressure, it can able to drain out in the easy methods. So such a pressure relief, pressure maintenance, unloading are done by the pressure reliefs various valves. So these are the various two images I have given for sequence valves and the counterbalance valve. Similarly here also we have the main pressure applications, and where it should be secondary port to the processing of the various flow rates. It means various pressure maintenance are possible. The same control balance of a tank and the remote operations, and the loading has been done. Required loading, how much it is. If it is extra, it should, we have given some additional pressure to take the releasing actions. So this is how we are doing the main operations. The summary. In this class of about regarding the actuating systems, we have seen about the control valves. And in this we have seen about the direction control, and then the pressure control valves. We have direction control, pressure controls conditions we have seen. In general we see in the actuating systems, we have done about the electrical actuating, and then we have seen about the hydraulic actuating, the pneumatic actuating devices. These actuating devices have the controlling units, control valves for this two hydraulic and pneumatic actuating systems. Here in the electrical we have seen the DC, AC, stepper and servo. Right? And also we have seen about the hydraulic, pneumatic and hydro-pneumatic. So such cases are possible to do the mainly of this actuating system. Mainly of this actuating systems we have done. Seen electrical actuating, hydraulic actuating, pneumatic actuating. Electrical having DC, AC, stepper, servers, electro-hydraulic, electro-pneumatic and hydro-pneumatic. To all these hydraulic pneumatics, we need the control valve to open, to close, to pressure relief, to maintain, to loading, to unloading, various condition of factors. The remaining part of the subjects will see you in the next session. Thank you.